This video was brought to you by Indently.io, learning Python made simple.
How's it going, everyone? In today's video, we're going to be covering the difference between append and extend when you are working with lists. But let's get started by creating a list, which will be of type string, and that's going to contain the values of A and B. Then we're going to duplicate that and create another list. And the reason I created two lists is because I want to show you the differences between append and extend side by side. So, to keep it simple, L1 is going to append one element, which is going to be C. And that's what append is used for. It appends one element. It can be a list, it can be a tuple. As long as it's one element, you can append it to the list. Now, Pyrite is complaining because obviously I said that this would be a list of type string, but here I'm adding another list. But if you were to print this, you'll see that you can add that element to the list, as long as it's one element. But let's change that back to C. Extend, on the other hand, allows you to add as many elements as you like. All you have to do is pass in an iterable. So here we can pass in C and D, and when we print L2, you'll see that we're going to get those elements added to the list. And since a string is iterable, we could also just type in C and D, and it would add both of those elements to the list as well. Moving on, I want to show you some common misuse with this. So what I'm going to do is remove this print statement, so it can be side by side with the other print statement. And here we're going to append Bob and extend Bob. And funny enough, both of these are going to work. So when we run this, what we're going to get back is a list with 3 elements and a list with 5 elements. But as you can see, one of them did something completely different. And that's because, once again, a string is iterable. So it dissected this, extracted each element, and placed it as its own element. So that's something you should always consider when you're using append and extend. Now let's move on to the operators that you can use instead, because some of you might be asking, why aren't you just using plus equals or the addition operator? So let's do just that. Let's remove all of this, make these two empty lists, and start creating some operations. For example, L1 equals L1 plus 1 and 2. Then we can print L1. And something else I want to do is L2 plus equals 1 and 2. And print L2. Now if we run this, we should end up with two lists that have the exact same output, because plus equals and plus are practically the same thing. But there is one small subtlety that you should be aware of, and that is that this is creating a new list every time you perform this operation, while this one's only affecting the original list. And we can demonstrate that by printing the IDs. So print the f string of ID of L1 equals. Then we can grab that and print it immediately under. And we're going to do the same thing for L2. Just need to remember to change those. And I might just swap the order of this so it looks like L2 or this block over here. But now when we run this, you should notice that L1 started with its original ID and then it changed immediately after, while L2 maintained the same ID. Because all we did there is modify the original list, while with L1 we created an entire new object as soon as we modified it. So that's just a small detail you should be aware of when you're using these operations. The in-place operation is not going to create a new object, while this one over here will. Now that we're approaching the final part of the video, I do want to mention that I got a lot of this research from a Stack Overflow question, which I found to be quite interesting. So I'd like to thank Aaron Hall for posting this response. I know this post on Stack Overflow is around 10 years old, but still I found it really interesting. It made me understand Python a bit better, and obviously it led to the creation of this video. So I'm going to be leaving a link to this in the description box down below, in case you want to reread it or in case you want to copy the code that he has. My code was slightly adjusted for this video, so it's going to be a little bit different, but the concept is the same. So, moving on, we're going to be creating a little benchmark on what happens when you use the wrong tool for the job. Because if you use append where you should be using extend, or you use extend where you should be using append, that can result in a little time loss. Now the time loss is quite insignificant, but Again, just use the right tool and you'll be rewarded with efficient code. So here we have two functions, one that appends and one that extends. And the append function takes a list, which can be of any type, and an iterable to iterate through. Then here we check for each item in that iterable and append it to the list. So we are manually doing what extend does using a for loop, which can be a lot of work for Python. Then for the second function, we have extend, which literally just extends the list. It's the same as the append function, but we use the appropriate method to perform this action. Then to time it, we're going to use timeIt.repeat, which will run the test 1,000,000 times and repeat that 5 times, and then take the minimum or whatever was the fastest from that result. And all we're doing here is calling append directly and trying to append the alphabet to an empty list. And we're doing the same thing for extend. Now when we run this, it's going to take a second or two, but you're going to see that append was much slower than extend, up to 4 times slower in this case. And that was the result of running it 5,000,000 times, so there's not really anything to take from this. Don't take this as an optimization, just take it as do the right thing because it will be more efficient, even if it's by an insignificant amount. Because eventually, if you start doing the right thing in lots of places, you're going to start saving a lot of time. If you are careless and start using append where you should be using extend and start doing other things in other places, you can easily start losing a lot of time during the execution of your scripts. But again, huge disclaimer, this is not an optimization. I'm not here to tell you that one's more performant than the other. I just wanted to show you that there is a small reward for doing the right thing or using the right tool for the job. Also, the results may vary depending on the length of your iterable. And that means that if they were to only contain one element, both of these are going to pretty much end up being the exact same time because they only performed one operation. But now imagine you have a string that is 200 characters long, so I'm just going to multiply this by 200. You're going to feel the difference immediately because it has a lot more work to do in the append function, and it's still running. But as you can see, if we go back down to what we did, as soon as we had 200 elements, this took a lot more time than extend. While if you're just appending one element, it doesn't really matter. But yeah, that's actually all I wanted to cover in today's video. I thought it would be more informational because I know it's a very simple topic, append versus extend. It's one of the first things you learn when you are starting to learn about lists. But still, I thought it was quite interesting. I find a lot of the questions on Stack Overflow to be quite interesting. So if you ever have some free time or you want to improve your Python skills, I absolutely recommend just scrolling through the Stack Overflow questions. I find them always to be interesting because there are a lot of passionate nerds there that really know their stuff. And usually you see a lot of debates. Some of them aren't so friendly, some are more friendly. Who cares about that? There's so much information there that you can learn from. Anyway, I'm going to end the video here. So as always, thanks for watching and I'll see you in the next video.